I'm going to introduce Rob from Cloud House, our Azure certified gold partner, to show you how to beat network latency. Just move your application to Azure, and it will run as fast as it was before on-prem.
Hello. Can everyone hear me all right? Excellent. Thank you, Lindsay. Thank you for including us in this presentation at last minute. And also, yeah, it's been quite exciting working with you the past few months. So I'm here to talk about our product, which is called Data Anywhere. It's basically something that uses machine learning in order to overcome network latency. We can predict the future, where we can predict parts of the future. We know what your app is going to do. We can predict what queries you're going to run, when you're going to run them, what parameters they'll have, and in what order. We've developed machine learning algorithms that can learn all this information automatically just by looking at the traffic that goes between your app and SQL. And we use that information to issue the statements to the database before you do, with the idea being that you can give significant performance increases from that. Before I go into too much detail, I'll explain what the actual problem is. Network latency. Give an example, the network latency from here to where I'm from in the UK, it's about 180 milliseconds. That's pretty fast. It's a third of the speed of light, but 180 milliseconds is bad for an application. Anything over 100 milliseconds, and your user will report that the application is not responding instantaneously. That's when they consciously recognize it. So that one call to the UK takes you over that. But even if you're talking about much smaller network latencies within the US or even inside a city, you've only got to have a few queries and the app will become unresponsive. We quite regularly see applications that have 20, 40, even 60 queries every single time you click a button. So these applications work fine on a LAN, but now they're trying to stick them in the cloud. They become unusably slow, perhaps even crashing from timeouts. And to be honest, even if your network latency was only like 10 milliseconds, still these applications will become really, really slow. So we wanted a solution for that. Also, it's not just about putting stuff in the cloud. Also, say, disaster recovery. Maybe your database failover is in a different region, so you usually have a very low latency environment, but suddenly you've now got high latency. So if your app becomes unusably slow when you're in a recovery mode, it's not really a recovery. Or maybe you solve network latency with something like database replication, and that's getting very complicated. This is an alternative to that. To go into a little bit more detail, it's a very simple diagram. So this is an application talking to SQL Server, issuing 3 queries, A, B, and C. But the point I want to make is this represents a single operation. So if this was like a visual application, maybe start is when a button's being pressed and the screen only refreshes once you click end. But it doesn't need to be graphical. It could be an API call. So that's your app server making 3 calls to the database. So start is when the API call comes in, and end is when it can service the request. And basically the problem is when you introduce higher latency, the round trip times basically mean that it takes all the extra time. The more queries you have, the more susceptible you are to latency. And obviously the higher latency, the more the delay is going to be. How does Data Anywhere help? So Data Anywhere basically acts as a TCP proxy between your application and SQL Server. There's a Data Anywhere server, or DA server as it is up there. And basically what that's doing is monitoring what queries go to the database and building up a model of how your application works and how you use parameters through your various different workflows. After a while, it can make predictions. I say a while, it's actually quite quick. It only takes like 2-3 times before it's learned how to predict. In this particular scenario, it's noticed the sequence ABC. So what it can do, once it's seen query A, as soon as it's got the response to that, it can issue query B in the same connection, and then query C, and stream them down to Data Anywhere client. Data Anywhere client will queue those responses, and if the client, your application does actually request them as predicted, then it can issue them back to the application. If it doesn't request them, it just throws them away. And that basically saves all these round trips, so you can see that big time save there. And the more queries you'd have, the more time it would save. It's crucial to note that it hasn't changed your queries at all. The queries that hit the database are exactly the same queries that you would have issued anyway. So that maintains SQL's consistency model, and it also means that, I mean, if you connect your application to a data client as if it's the database, we guarantee all the same guarantees that the database. So you don't have to change your application. There's no code changes in order to use this technology. There's no custom configuration. You just use it as a TCP proxy and eventually, well, as I say, very quickly, speed up your connection. The other thing to note is the learning data is all on the server, so you could have thousands, tens of thousands of users connected, and only one of those users actually needs to learn it. That learning data is then available too. So the ramp-up time is very fast with this. So how does that work?
There's no application change, right? So
yeah.
you basically just the same application, no re-architecting, no anything, right? Just move your database to a PaaS service. Your application going to run as is. You're going to have all the benefit of PaaS without actually taking lots of capital investment on re-architecting your application.
Yeah, and that was a big thing for us. I mean, lots of people have got these applications that are very successful, were working in a LAN environment, but just become unusable. So they go through the process of trying to rewrite it so that it can work with high latency. And quite a lot of these projects get abandoned because it just takes so long to do. Whereas there's no code changes to this. You could get it working in minutes, basically, and see it up and running.
Yeah, change a connection string. There you go.
Yeah, change the connection string, plug it in there, and away you go. Yeah, with a free trial, which I'll go into a bit more detail at the end so you can try. How does this work in practice? So presumably most of you have heard of Sage. Sage, as an example, we prefetch 57% of the queries, and that gives us 1.88, so nearly doubling the speed performance increase. Incidentally, we actually predict a lot more of their queries than we prefetch. So for instance, we don't prefetch writes, we don't prefetch updates, deletes, inserts. For Sage 100, an example of a write would be raising an invoice. Believe it or not, people don't like it if you raise an invoice automatically before somebody's actually instructed you to do so. Some people might like that feature, but other people like to wait until the user's actually done it. Yeah. So we don't prefetch writes, and there's kind of gray areas, things like set statements, which change the state of the connection, but don't change the state of the database. We can actually prefetch those. We just need to roll them back if our prediction happens not to be correct. There's also this concept of effective latency, which we put in there. If you use Sage on a 40 millisecond WAN, it would run as fast as if the latency was actually half of that with DA. And the other thing to point out, this is early days for DA. At the moment, it's prefetching 57%, but we're predicting that figure is going to go up quite significantly as we prefetch more and more of these. So that workflow would be that fast at this stage, but with each new release of Data Anywhere, it would be faster and faster. T-Plan and CareSys are probably haven't heard of, but they're a couple of customers of ours that have similar performance increase, doubling the speed. Microsoft Dynamics Nav, we actually prefetch 95% of their queries, which makes it 16 times faster. Now, that's a three-tier application, and so the acceleration we're talking about is between the app server and SQL. Again, you'd probably have your app server nice and close to SQL normally, but again, for something like disaster recovery, you may introduce that 40 millisecond latency, but with DA in there, it would bring it down to a LAN-like latency of 2 milliseconds. Seeing is believing, so this is an example of one of our customers' apps called T-Plan. We're going to run through a workflow so that you can see that the performance is visually noticeable. So almost immediately you can see that with Data Anywhere, it's faster on the right, all the button clicks are more responsive. So they're both running through a 60 millisecond latency.
Network latency, right? 60 millisecond network latency, the same?
60 millisecond network. As you can see, Data Anywhere is already finished. Meanwhile, the one on the right, one on the left without Data Anywhere, you can see it's sluggish. There's progress bars. There's that spinning wheel of death. and generally your users getting frustrated. And what we're bringing it from being something that's so unusably slow that people just don't want to use it to being something that actually people will buy and use. So there you go, 17, 18 seconds faster with data anywhere in this particular example, doubling the speed that it was before.
Yeah, I see if there's no difference, right? It's like, but it was before in on-prem.
Yeah, exactly. So bringing it down to online speeds. So I've made a lot of bold claims as part of this. I don't have time to answer them now, but we'll be at the, me and Stu, who's back here, find us in our orange t-shirts, which are very different from all the other orange t-shirts that are around. Yeah, we're going to be at the Microsoft SQL booth. Challenge us. We can answer all your questions about it. We're really keen for you to actually try this. We've tried to make it as easy as possible. So there's a free trial available on our website. Play with it, put your app through it, see how much we predict, see how much we prefetch, see how much faster we can make your app. Give us feedback. We also have a Twitter handle. We don't have very many followers at the moment because we set it up a couple of days ago. But yeah, follow us on Twitter. Yeah, thank you very much.
Thanks, Ralph.